All right, I'm gonna write out the generic form of the function. And it's gonna look like I'm jamming every letter of the alphabet into this because it's the like in general form, but just stick with me, okay? Y equals or f of x equals a. And then I always write trig there because it could be sine, cosine, tangent, cosecant, secant, or cotangent, depending on what the problem is. But like whatever the trig function is. And then inside, you're gonna have b times x minus c, and then at the end, plus d. So you have an a, b, c, d in there, and I'm gonna talk about what all of those mean. Amplitude is the absolute value of a. So whatever that coefficient is, you just make it positive, that's the amplitude. When you have a wave like this, you have this center line. The amplitude is the distance from that center line. This is your amplitude. I'm not great at drawing, but like, do you get what I'm saying? Like when you have a wave, you have that center line for the wave. The amplitude is that distance you get from the center line. So that's A. In other words, that's your vertical stretch or shrink. If you want to relate that to what we've done before, that's your vertical stretch or shrink. Because you can have a regular looking wave, or if you stretch it taller, you can have a really tall wave. Do you guys do sound waves in science? What is that in physics? You do that? You know what I'm talking about? They look like that. It's the exact same thing. Oh, did you do that in middle school? Like yeah, that's what it is. So you can have a really tall wave, or you can have it like a squished wave. Anyway, that's the vertical stretch or shrink. The period is 2 pi over b. And again, we absolute value that because the period is the distance it takes to finish one full cycle, and a distance can't be negative. If you want to relate this to what we've learned before, this is your horizontal stretch or shrink. So if you take the graph and stretch it like this, like if you stretch it horizontally, it's going to take longer to complete one full cycle. If you scrunch it together, then you finish one full cycle faster. So it's just your horizontal stretch or shrink. We're just giving it a new vocabulary word, that's all. Phase shift is this C value, and that's the amount that you moved left or right. So remember when I said state the transformations, and you would be like, it went left 7, you know, like, or right 3. That's exactly what that is. That's the left or right shift. And then your vertical translation is D. That's the amount that it moved up or down. So that's like up 5 or down 2 or whatever it is. So they are all things you've done before. We are just giving it new words because it's a wave graph. Okay, it's a trigonometric graph. Now the range, again, I'll attempt to draw this. So you've got this wave, you've got this center line. That center line is wherever D is. So like if your graph did not shift up or down, it would still be centered at 0. But like if you moved up 2, then your center line would be at 2. Or if you moved down 3, it would be at -3. Anyway, that center line is going to be whatever your vertical translation is. And then this distance is A. The distance from the center line, that's your vertical stretch or shrink. So your range, how could you get this low point? If D is the center and this distance is A, how could you figure out that value? Yeah, D minus A, good. Your low point is going to be D minus A. And then what's your high point going to be, like the high point of the wave? D plus A, good. It's the center line plus or minus whatever your amplitude is. We're just going to try a few, okay? We'll do these first 2 and then I'll give you a break. Now here's my suggestion. Either take a different colored pen or a highlighter or something. You want to highlight the actual trig function. So it'll separate for you in your mind what's inside and what's outside the function. I'll pause there because you all like reach to get a pen, which is awesome because you're listening to me. So I'm going to just wait a second. Again, I just always say to highlight or like circle that or put a line around it or something. That's what's inside the function, and then everything else is outside the function. It helps you separate what's inside and what's outside. Put the phone away. Now, a whole lot of this is like automatic answers. And it's going to be this way on your test too. You can fill most of this out without even getting the graph. So they're very forgiving, because I get people that are like, I'm really stressed about drawing the graph. Well, I make each one of these lines worth a point, and you can get all of this without even drawing the graph, if that calms you down at all. All right, what is the domain going to be for sine? All right, look, you already got a point. It's a wave. It goes forever in both directions. It's going to be all reals. All right, the range. Do you see how this one moved down 4? There's a -4. That center line is going to be at -4. Imagine that with me, right? The center line is at -4. And then do you see that 3 out front? From that center line, you went 3 down and 3 up. So what's the lowest point going to be? Good, -7. And then again, still centered at -4. If you go 3 above that, -1. You got that without even drawing the graph. You just add or subtract, okay? Amplitude is 3. That's your vertical stretch or shrink. That's just the number that's out front. Just remember to absolute value it. Like if it was a -3, you would still put 3. All right, period. It would be 2 pi divided by whatever b is. B is going to be whatever's in front of the x. Do we have anything in front of the x? No, so it's just going to be 2 pi. What that means is there's no horizontal stretch or shrink. It did not get stretched or shrunk horizontally. It's just still going to be 2 pi. Phase shift is left or right. Do you see anything changing inside of here? No, so 0, or you could say none. There just isn't one. It did not move left or right. And then the vertical translation would be -4, or you could say down 4, however you want to say that. Negative, just the value -4, or you can say it moved down 4, however you want to say that in words. Oh my gosh, look, we answered all of that. We didn't even draw a graph. Isn't that cool? You can get so many points like without even really doing much, okay? Now, when you go to get your table of values, you're going to start with whatever is the phase shift. So if it shifted left or right, that's where you're now going to begin. This one didn't have a phase shift, so we're still going to start at 0 pi. You can put either, but I recommend putting the pi with it so you don't mix it up with one of those coordinate point zeros. Do you get what I'm saying? Like, I feel like it's easy to mix them up if you don't put the pi. So start with wherever your phase shift is. And then the length of this should be the period. That's how long it takes to complete one full cycle. So what did we say the period of this function was? 2 pi. So if you start at 0 pi and you go 2 pi, where are you going to end? 2 pi. Yeah, don't overthink it. I made the first one fairly easy. 2 pi. Now here's where it becomes fun with fractions. You have to break this down and figure out what goes in between. Again, that made the first one fairly easy. What's halfway in between 0 and 2? 1, so 1 pi, and then what would have to go here? 1/2 pi, and then this would be 3/2 pi. But listen, that ends up being the really hard part. Getting this, that's the hardest part of this entire process, because it like I made the first one fairly simple, but it gets really messy with the fractions. So here's what I always tell everybody. You can get all of this and all of the other side of the chart without that. If you get stuck on the test, make something up. Do you get what I'm saying? Like, or if you're like, I just absolutely can't do this. I feel like I probably shouldn't put this on the recording, but if you just absolutely can't do this on your test, make them all 0 to 2 pi. You'll lose the point for that, but then I can read with you on everything else because you can literally get the rest of it. Does this make sense? I want you to learn it, but if you just struggle with it, it's going to be okay. Now, ignore that. What you're going to do to get this side of the chart is go around your unit circle. I drew it up there, but on your test, you're going to want to draw it at the top of every paper. It does not matter what this says. You're just going to go around the unit circle. This one's sine, so are we going to use the y values or the x values? We're going to use the y values, and then you're going to multiply them by 3, and then subtract 4. What's your first y value? 0 times 3, 0 minus 4, -4. Keep going around the unit circle. Now we're at the top. What's the y value? 1 times 3. 3 minus 4. Now we're on the left side. It's 0 times 3 is 0, minus 4 is negative 4. Now we're at the bottom. What's the y value? Times negative 3, or times 3 is negative 3. Sorry, my brain said the answer. Minus 4, negative 7. And then the last one's going to put you right back where you started. It's cyclic. All right. Now, when you go to put those values on here, you have to label the x-axis. We counted by pi over 2. Do you see that? You don't have to label every single one of these tick marks. If you do a couple, that's good enough for me. If I want this to be pi over 2, that means this would be 1 whole pi. And then this one would be 2 pi, and this one would be 3 pi. Let me zoom way in on that. Yes. Yeah, and I get a lot of people that'll do that. So instead, they'll make like this one 1 pi. Is this what you meant, Caleb? Like this would be 1 pi, and then over here would be 2 pi, so you have like more room. Yeah, yeah, as long as you are consistent. And then we're just going to plot these. So at 0 pi, we were at negative 4. This one's going to go off the grid. Oh, well. Well, you know what? Here, let me do this. Let me put tick marks halfway through so it will stay on the paper. So at 0 pi, we're at negative 4. And then at pi over 2, we're at negative 1. And then at pi, again, we're at negative 4. And then negative 7. And then back to negative 4. Now that's one period of the function. I require that you show at least 2. And what I'm doing with that is making sure you can continue the pattern. So just keep it going. And I don't care which direction you go, it does not make any difference to me. But just keep the pattern going for at least one more cycle. So at least like that. And if you want to, this is optional. If you want to dot in that center line so you can see where the center is, you can do that. You do not have to. That's not an asymptote. That's just me showing where that center line is, because sometimes that helps. Again, you don't have to do that if you didn't like that. We'll try one more and then I'll give you a break. All right, but again, it's a drill and practice thing. So you got to just do a lot of them to get the hang of it. Oops, sorry. So if you want to highlight, and I think that this helps, you're going to highlight the trig function and everything inside of it. For number 2, that's practically the whole problem. The only thing that's outside of the function is that negative. Everything else is inside. It's sine of all of that. But again, you can answer like most of this because it's like automatic answers. What is the domain going to be? All reals. It's an automatic answer. Let me come back to the range because actually it'll be helpful if we answer some of this stuff first. Amplitude. Now there's a negative in front of there, but it's really a -1. You have to absolute value that. So absolute value of -1 is 1. Good. All right, the period. It's 2 pi divided by b. B is whatever's in front of the x. This is your horizontal stretch or shrink, and I did put one on here. It's 2 pi over 1/2. When you divide by 1/2, you are multiplying by 2. It's the reciprocal. So what is that going to come out to be? Good. 4. Okay, I woke you guys up. So instead of 2 pi, now it's 4 pi. We stretched it like this. Like you took a spring and stretched it left to right. All right, phase shift. That's left or right. Using what you've learned before, did this move left or right? Right pi. Good. You can either just put positive pi or you can say right pi, whatever is your preference. And then vertical translation would be what's added or subtracted outside. Do you see anything out here? No. So you can say 0 or none. So let's go back to the range. If it didn't move up or down, your center line is still at 0. And our amplitude was 1. So the center is at 0 and it's going to go up 1 and down 1. So what would your range be? Yeah, good. -1 to 1. It didn't get stretched or shrunk vertically. It got reflected. It's going to be upside down. All right, when you go to fill this in, this is the tough part. But remember, if you get stuck, just make something up. You're going to start with your phase shift, which for us was pi. And then the length of this should be like 1 full cycle, which is the period. So 4 pi. So hey guys, if we start at 1 pi and we want the distance to be 4 pi, what goes here? 5 pi, good. And then you have to break it down to go what goes in between, but I think we can just count by pi's, like 2 pi, 3 pi, 4 pi. It's nice when it works out that way. But if you get stuck on that, you can get this half without that, because you're just going to go around the unit circle. Are we using the x values or the y values? We're using the y values because it's sine, and then we're going to make them negative. That's why I tell you to block this off. This is what you get from your unit circle, everything that's inside, and then you just have to do the stuff that's outside. In this case, it's just a negative. What's your first y value? 0 times a negative would still be 0. Then you're up at the top. That would be 1, but we're going to make it. And where I hope you're going to end up is that you can continue this without thinking too much. What's the next one going to be? 0, and then 1, and then 0. Once you get it started, you just kind of keep it going. Now you can label each of these tick marks pi, but I liked your suggestion. I would probably skip a couple, because if you have 1 pi, 2 pi, 3 pi, it's going to like feel really scrunched together. So I think I'm going to do like every other one. And I'll zoom in because I know that's real small. But when you go to label that, that's sort of personal preference, like how you, I mean, as long as you're consistent, I really don't care how you do that. And then we're going to plot these points. At pi, we're at 0. 2 pi is -1. 3 pi back to 0, then +1, then back to 0. Again, just try not to make it like jaggedy like a jack-o'-lantern mouth. That's 1 full cycle. All I want you to do is continue it for 1 more cycle, just to show me you can continue the pattern. And I don't care which direction you take it, it doesn't matter to me, but just do 1 more. Or go crazy. You can fill the entire grid if you want. I get some people that'll do that. They'll just keep on going. Oh, whoops, but I didn't put my points in the right spot. All right, we're doing good on time. Take like a 2-minute break and then we'll try some of the ones on the back, okay? So hey guys, this one says cosine. Literally the only difference is when we go to get our values from the unit circle, what are we going to use? You're going to use x instead of y. Again, I would block off the trig function and everything inside. That's what you get from the unit circle. And then you would just subtract 1. So it's cosine of all of that. That's what you would get from your unit circle. And then you would just subtract 1. But again, you can get a lot of this without the graph. What's the domain? Yeah, all reals. That's like an automatic answer. Let me come back to the range because you kind of need this to get the range. Amplitude. There's no number out front, which means it is what? 1. You can't have an amplitude of nothing. Again, an amplitude is that distance from the center line. That can't be nothing. This is like a 1 coefficient in front of cosine. All right, the period is 2 pi divided by, because it's typically 2 pi unless you have a stretch or shrink. Put the phone away. It's 2 pi divided by whatever's in front of the x, which in this case is 2 pi. So what is that going to come out to be? Well, actually, even the pi cancels, so literally just 1. That's kind of cool. All right, phase shift, that's left or right. Did this graph move left or right? This is what you want to look at in here. Left 1/2. You can say -1/2, or you can say left 1/2, whatever is your personal preference. And then the vertical translation is up or down. Did this move up or down? Down 1. So you can either say -1 or down 1, whatever is, however you like to say that. So when you go to do the range, your center line is at -1. So imagine that with me. Your center line is here at -1, and your amplitude is also 1. So your center is at -1, and you went 1 unit above and below that. So what is your range going to be? Perfect. -2 to 0. Now here, I'll show you. You can get these values without the x's. Getting the x's is tough for people. That's why I teach it in a way that they almost don't matter, so that if you can't get them, you're not lost for the rest of the problem. You can get these values without the x's. You're going to go around your unit circle. Again, it's cosine, so we're going to use x, and then just subtract 1. Just do whatever's outside the function. What's your first x value? 1 minus 1, 0. Keep going around the circle. Now you're at the top. What's your x value? 0 minus 1, -1. Good. So we're continuing our journey around the circle. Now we're over here. What's your x value? -1 minus 1, -2. And then what's the next one? -1, and then you're back where you started. The first one and the last one are always going to be the same, again, because it's cyclic. You end up where you started. So whatever you put for the first one, that's going to be the last. So again, you can get those without even getting the x values. So if you struggle on the x values, make something up. It starts with the phase shift. So what was our phase shift here? -1/2. And then you want this distance to be 1 cycle. So the period of the function. So what was the period of the function? 1. All right. If you start at -1/2 and then you add 1, where do you end up? 1/2. Perfect. And then you have to break it down to what's in between. So I usually do like halfway in between. What would be halfway in between -1/2 and +1/2? 0 would be halfway in between. Now here's where the fractions get a little tougher. You have to break down further than halves. Good, fourths. So this would be -1/4, and this would be +1/4. That can be tough, because what if you have to break down fourths? What would fourths break down into? Oh, good, 8ths. And then 16ths, 32nds, 64ths. I mean, I wouldn't go that far, but oh, okay, that seems like that went all right, because fractions are what everybody struggles with, right? And do you see how none of those have a pi in them? That's because the pi is canceled out, so that's cool. All right, so labeling your x-axis. Each tick mark is going to have to be a fourth, because we broke down into fourths. I don't want to write 1/4, 2/4, 3/4. That's really annoying. So if that's 1/4, 2/4, 3/4, this would be 1, and then this would be 2. That's what my suggestion is. You can label as many of the tick marks as you want, but if you want each of them to count as 1/4, just go to the fourth one and call it 1. Is my suggestion. You can label them all if you want, but I think that's annoying. All right, and then we're going to plot these. So actually, let me go this way, because I've got some of them that are negative. So this would be -1. So I've got -1/2, 0. That would be right here. And then -1/4, -1. And then 0, -2, and then you're just going to kind of keep that going. So that's 1 cycle, and I just want you to continue the pattern at least 1 more cycle. You can go further if you want, but I just want you to continue it at least once more, just to show me you can keep the pattern going. And if you want to dot in the center line, you can. You don't have to, but if you want to dot in that center line, if that like helps you. Actually, I think I forgot to dot in the center line on this one. Yeah. Oh, well, you know what? The reason I forgot on this one is because where's the center line? Yeah, it was like on 0. That's why I forgot to do it on that. You can always do that if you want to, if that helps you like visualize. We'll do one more together and then I'll show you delta math. I'll fill in the last one if you wanted it for extra practicing. All right, block off the trig function. That's the part that's inside. So whenever you get your values, you're going to go around the unit circle and then just multiply them by a half. You only have to take care of anything that's like outside of the function. All right, so domain, all reals. It's an automatic answer. What would be the amplitude for this one? 1/2, good. That coefficient. So this one's scrunched. It's like an elephant came and sat on it. It's a vertical shrink by a half is what we did. All right, the period is 2 pi divided by whatever's in front of the x. There's nothing written there, so what's in front of the x? 1, good, so it would just be 2 pi. In other words, it did not get stretched or shrunk horizontally, which is always nice. Like that, it's difficult whenever that stretch or shrink goes in there. Phase shift, left or right? Did this graph move left or right? Left, how much? Pi over 4, good. So you can say negative pi over 4, or you can say left pi over 4, whatever is your choice. And then vertical translation, did it move up or down? No, so you can say 0 or none. So to get the range, that center line is at 0 and our amplitude was a half. So you went a half above it and a half below it. So what is your range gonna be? Good, -1/2 to +1/2. Your center was at 0. It's always easy when the center is at 0. It's actually here, I'll go ahead and dot that in. Your center line is gonna be on the x-axis, which you can't really see it all that well. It didn't move up or down, so you're still centered at 0, which is nice. So again, you can get all of the f of x values without the x values. So let's go ahead and do that. You're going to go around the unit circle, take all the x values, because this is cosine, and then multiply them by a half. So what's the first one? Yeah, 1 and then times a half, 1/2. Now you're up at the top of the circle. What's the x value? 0 times a half, 0. Could you keep it going? Just like think about what the cycle would be. What's the next one going to be? -1/2 and then 0, +1/2. Like you can just keep it going. Because this is the hard part. All right. You start with the phase shift. So our phase shift was -pi over 4. That's where it got shifted. So that's where you have to start. That's like, it's annoying when that's in there because it's like, I didn't start at 0. And then the length of this should be 1 full cycle, which we said was how much? 2 pi. Okay, here's where it's fun with fractions. You have to take -pi over 4 plus 2 pi. My suggestion is leave off the pi. It always throws everybody off, okay? We're doing -1/4 plus 2. So how many fourths is 2? 8, good. So that would be 7/4. So 7 pi over 4. And then you have to break it down to what's in between. I think this one we can just kind of count, like this is -1. I think we can do 1/4, 3/4, 5/4. I think they all come out odd. The more you do this, the better you'll get at like finding the pattern. But do you see how I just counted by all the odd ones? It was -1, +1, 3, 5, 7. Again, that's going to come from practice and number sense, right? But I said, if you can't get that, make something up. You will lose 1 point and that's it. Now, when you go to label, do you see how these are broken down into fourths? Don't label each one of them with fourths. That's going to be annoying. Just go to the 4th one and call it pi. You don't want to have to label every single one of those. That's going to be really, really annoying. Now this one's going to be really like low, like if we scrunched it by a half. It's a vertical shrink by a half. So negative pi over 4, a half, that's going to be right there. And then pi over 4, 0, that's going to be right here. And then 3 pi over 4, negative a half. And then back to 0, and then back to positive a half. And again, I just want you to continue it a bit further. Like this is one cycle, so just do one more. And it doesn't matter what direction you go. Yeah. Is that good? Okay. No, you're fine. The only problem with zooming in is then if you wanted to see something else on the page, it's kind of like once you zoom in far enough, I can't show you everything at once, but yeah, go ahead. Yeah, so like that's a personal preference. So like what he's asking is like, did you want to call this a half instead? Yeah, as long as you write it, you can label it however you want, which makes the test super fun for me to grade, because if everybody labels differently, then they all look different. It's like, but I mean, that's my problem, not yours. So as long as you label it, I don't care. All right, let me show you delta math real quick, because this is actually kind of cool. I want it to show up on the Zoom though, so let me share my screen. Okay, this is so cool. Do you guys see the solid line and then the dotted line? You have to turn the solid line into the dotted line, but you can't get them wrong because there's a try button, and if it's not right, you just don't hit submit. Okay, so you like can't mess it up. Now look, do you see how we're starting here? And then this is one full cycle. Did the cycle change? No, it's the same. So we did not have a horizontal stretch or shrink. Did it move up or down? It's centered at 0, 0, or like the x-axis. Do you see that? It's centered in the middle. So what am I going to put here? 0. Good. Now, but there was an amplitude. Do you see how the dotted one is taller? By how much? 2. So I'm going to put a 2 there. Do you see how I lined up? Then you would hit submit. If it's not right, just don't hit submit. Let's try another one. All right, do you see the dotted one? Where is the center line for the dotted one? Like, where is it centered? -2. So right here, I'm going to put -2. It went down 2. All right, let's see. Did the cycle change? No, it looks, I don't think any of these are going to have a cycle change because I made them the easier ones. And then amplitude from that center line at -2, how much above and below, or you know what, is it -2 or is it -1? But you know what, if I had gotten it wrong when I hit try, it wouldn't match up and then you can fix it. All right, so I'm sorry, -1 is the center line. How much above and below that center line did we do? 3, so your amplitude is 3. That's so cool. Love how it does that. All right, and then I had somewhere you're gonna write the equation. All right. And then I think this one, you're just gonna state what the period is. Here, let's go ahead and do that. It would be 2 pi divided by whatever's in front of the x. So you'd have 2 pi over 4 pi. Well, actually, the pi's would cancel. So just 1/2. Oops, not 1.2. Cool. Yeah.